Oh, that's not a pen. I grabbed a tablet marker. I'm thinking that's what's going to be able to write. Yep, sure. Yep, that writes on real paper. All right. So today, 6 point. Oh, I ran out of. I gotta lock this in. There we go. Boop. All right. 6.4, the triangle mid-segment theorem. I am also very mad that I don't. Oh, I don't even know what I've said. I'm not even speaking right now. I don't have a copy of my notes right now because I'm recording this on Tuesday. You guys are probably doing part of this on Wednesday, right after the quiz, because God knows you guys shouldn't have any free time after the quiz. And that I also feel like this is the best thing to do. So I have to do it tonight, and I don't have anything. All right, mid-segment of a triangle. A segment that connects the midpoints of two sides of the triangle, or of a triangle, and we'll abbreviate triangle with the triangle marking. And I'll just mark it. Oh, that's so bad. Head, no, it is 5:50 right now, so if that gives you any context of how I'm feeling right now. Every triangle has 3 mid-segments. That form a mid-segment triangle. And the beauty of having notes already is that you don't have to draw anything. I have to draw. So, let's consider this beautiful triangle I'm drawing right now. Yeah, I was like, why is it so dark? It's usually so bright when I film. That's why I didn't even have a browser open. Look, dude, it changed so drastically. See, now I can actually see what I'm writing. All right, so I guess I feel better now. Oh, it's so white now. Jesus. All right, we have triangle A, B, and C, and I have to write out the midpoints that I have right here. I shall call this one M, I'll call this P, and this one N. So what this is entailing, we have mid-segments that connect these midpoints. Also, remember what midpoints do? They make congruencies for these sections. So, see? These are all congruent. It looks like on AB, M is the midpoint, so AM and MB are congruent. Same with all the rest of these. So what this kind of statement is saying up here is that we can form a triangle in the middle as so. And all the vertices are the midpoints. That's the mid-segment triangle. It also looks like a triforce, which is why I put link on the cover. I don't know if you guys could understand that one. Anywho, there's this theorem that goes along with this, and it's the triangle mid-segment theorem. And I can break down this theorem into 2 parts. First part, the mid-segment is parallel to the third side. And 2, the mid-segment is 1/2 as long as the third side. Take note of this 1/2. That's important. So, and we're going to point this out. Looking back up at our figure, we could say dot dot dot. And we're about to list so much off. The fact that I'll write parallel lines first. We can say that the line MP, this line right here, is parallel to AC. This line right here, you can say those are parallel because of the theorem. We could also say that MN is parallel to BC because of the theorem. And we could say that PN is parallel to AB because of this theorem. Maybe we should write because of the theorem. Because of the theorem. So I don't have to keep saying it. You can't even really see the orange. It's too bright. And we could also write out congruencies. Like the fact that MP is congruent to AN, and it's also congruent to NC. Did I get that right? Yep. MN is congruent to BP, and it's congruent to PC. And we can also say that PN is congruent to AM and MB. All because of the theorem. And what you also should do right now is mark out your inner triangle. There you go. Now, with this theorem, and recognizing the 1/2, we can use that to solve for values, like problems. So I want to take this 1/2, we're going to move it down here. And I'm going to write 2 different equations that can help us when we start doing like numerical stuff, numbers. The fact that we could do 1/2 of big segment equals the mid segment. And we could also write that the big segment is equal to 2 mid segments. Remember that big segment is something like AC or BC or AB. So keep that in mind. Maybe you should take a note like big segment. Examples. AB, BC, AC. Just in case if you don't know what the big segment is, but keep this in mind. We can use this to solve problems, and we'll be working on problems right now. This is, I believe, the only thing, like the only thing, yeah, that's the only thing we're learning today. It's just this theorem. And that might be the only thing you guys are doing, like, after the quiz. Well, it depends on who finishes or not, I guess, but we'll see. Example 1. We're going to name a segment parallel to what's given. And we have an A and a B. For A, we're going to find CD. And for B, we're going to find QS. We got to find a parallel line. So let's draw out what I want. You know, we work with what we got. C, D, E, M, P, N, QS. It's a nice, easy one for QS. Pew, 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 pew. See, look at how much time this is taking compared to like what I had beforehand. Ugh. The worst part is that the notes that I have are done. Like, I just need to print them. All right. A. Where is CD? Let's grab our color pencil so I can color. It's this line right here. I need to find a line that is parallel to CD. In our case, it is PN. Now, well, in my case, they ain't parallel because I don't draw nice. But in your picture, it's parallel. And then we can do the same for B. We have to find QS, which is this line right here. And the line that's parallel to that is NM. So, NM is parallel. There we go. That's example 1. See, this isn't like actually that bad. It's just so much dang writing, man. I don't want to write so much for these problems. But I don't have the packet. That's the worst part. I'm just gonna complain. All right, we're gonna find the missing measure or the missing length in the next set. We got an A and a B to work with as well. I like giving 2. 2 examples are good. And we're gonna find CD for this one, and we got to find DF for the other. Now, this is a different picture, so don't be that happy. It might be the same labeling, but it is definitely not the same picture. So Z, X, Y, going down, we have C, D for that one, and I'll have to label it out with 16 and oh god. 16, and I will put down alpha. I don't know. I don't want to use a letter. There's so many letters right there. I'll use a Roman symbol. Oh man, it is late. And I have V and U. And on the inside, I have 9. And I guess we'll keep this symboling going up. I don't know what sigma is, but I do know what beta is. That is beta. Still looks like a B. We gotta find DF. We gotta find CD. All right. Take account with like how we already can use the mid segment. In our case with A, this is our big segment. You can match it with orange pen too. This is our big segment. And then this is the mid segment. So you can set up your equation as so. Like I know that this would be 16. And to get up to 16 with my mid segment, I'd have to have 2 of those. So 2 alpha. Now your problem probably has X. I'm gonna be real right now. This is probably going to be 2X. I only changed it because I noticed I had X right here, and I was like, oops, that probably shouldn't be right there. So I was on the spot. So divide by 2. And this mid-segment should be 8. And you can do the same thing for this, noticing that 9 is on our mid-segment. So this is the mid-segment. And that right here, DF, is the big segment. Oh, remember, you do not need to point this out to me, just do the blue. The orange is for helping you see what we are doing. So you can do this one of 2 ways. I am going to do this the other way. Instead of having 2 of the mid segments, I'm going to do 1/2 of beta is equal to 9, and just solve from there. I multiply by 2 to get rid of that fraction, and I'd end up with 18 for my ending. Simple enough. We got more. Almost done though. Example 3. We're going to find the value of x and AB in our picture below that I get to draw. I don't know if you guys draw this one. You might. I'm gonna be real. You might actually have to draw this. Maybe I didn't even add this. I don't even know what my notes look like right now. They're not out because I'm pretty sure the one I have in my I don't know. Oh crud, dude! No way that these points are right. Oh god. All right, I'm gonna be real. These points on this triangle, I think the points on the triangle are different. So if this is like A, B, C, just follow along. You're just gonna have to go along with it. Just roll with this outline. Because I don't know if these are the right points that I put on the triangle, if you even have one. So if these vertices don't match, it's okay. Just swap them out with what I do. It'll be fine. We're doing this. It's the same thing, but different. Just a little bit. JG, I'm giving myself 6x minus 3, and I'm giving myself AB, which is 2x plus 1. Okay. So I can actually solve for x and AB with this, with the knowledge of the mid-segment, and those 2 equations that I know of. So remember, this is the big segment, this is the mid-segment. What I could do is do the big segment, so I'm just going to write big, equals to 2 mid segments. If I do 2 mid segments, that will equal my big segment. So what I could do, I could write 6x minus 3 is equal to 2, parenthesis, 2x plus 1. I'm taking 2 of my mid segments, and my mid segment is AB, and I'm going to set that equal to the big segment, JG, which is 6x minus 3. This works. This is okay. I'm going to distribute this 2 out now. Give me 2x minus 3 equals 4x plus 2. And now I can solve for x. So get my 4 to the other side. That'll give me 2x minus 3 equals 2 plus 3. That'll give me 2x equal to 5. Divide by 2. And that shall give me an x equals 2.5. Yep. And now I can take this 2.5 and plug that into AB. So AB is going to be 2 times 2.5 plus 1. So 5 plus 1 equals 6, and that is AB. So x is 2.5, AB is 6. This is why I made you guys write that out at the bottom. Especially this. Because we can use this and plug in stuff like this. And we can solve for x in segments. We have a few more kind of like that in the bottom that we are doing as well. So you can see more of them. So example 4. Find the value of x and ln. And I have this figure right here. M, N, L, E, F. Draw the line. I have that. Well, I have x plus 2 here and x plus 10 down here. And again, taking my big segment, the big segment and the mid segment, I can write out an equation. I can do big equal to 2 mid. So I could do x plus 10 because ln is my big is equal to 2 times x 2 my mid segment x plus 2. And then I can distribute my 2 out, giving me x plus 10 is equal to 2x plus 4. And I can solve for x, giving me x equals 6. Yes. X equals 6. And then I can plug in this to get ln, which ln is equal to x plus 10. Which, if I plug in 6, that will give me 16. This isn't too bad, I have to say. Gotta section this off. Example 5. This might be like 4A, 4B for you guys, but I want it to be 5 right now. We're gonna find the value, that's not how you spell value, of x and VW. So, see, that's how I should have drew one of the pictures. I don't know what I was doing before. Not this, that's for sure. All right, this is M. We got W, V, N, and L. I also have negative 2x minus 6 right here. I have x plus 21 right here and x plus 15 right here. So this is all about knowing what information you have and need to use. And the fact that this is my big segment I'm working with, and this is my mid segment that I have to find the value of, because this is VW. I don't even need to look at this negative 2x minus 6 because it's not even part of the plan. I just need to focus on the orange ones because this is my mid segment, the one I actually have to find the value for. And the big segment that goes with this mid segment is this one right here, ln. So I only need to look at these two values. I don't even need to worry about this. This is called reading the information that you have and figuring out what's actually useful for you guys. So I can set up the same equation. You don't have to write the orange. You don't have to write every time big equal to mid. I'm writing it though. So you don't have to. Well, you do not have to, but I'm going to do it so I can set up my problem so I can have success. I forgot to put my 2, so I'm going to put it right here. Distribute it out. So now I have x plus 21 is equal to 2x plus 30. I'm going to move my x over to this side, so I have 21 equal to x plus 30. Going to move my 30 to the other side, and I have negative 9 equal x. That's okay. And now I'm going to plug in this negative 9 into VW. which is equal to x plus 15. And that means if I plug in that x in, I'd have a negative 9 plus 15, which is 6. And that's it. Not too bad of an actual go-through of this stuff. It was just more of a pain for me because I had to write it all. But to each their own. Hopefully you guys are okay with this.